Hello everyone, welcome to the day 9 sessions. So we are going to discuss about Arduino input and output functions, how to configure your pins to work as an input or to work as an output. So let me just run on yesterday's session. So we have been just seeing what is how to have an array accessing. So these are the things we have been just seeing in the yesterday's session. Int is equal to 0, I less than 10. You have been initialized some of an array and you have been printing those arrays. So this was another version having a least like array function. So you have been printing it. So these are the various array actions. So you can use a for loop as well in order to use some kinds of array operations or something like this. So these are all the some of sessions what we have been just seen in the yesterday's or in our previous video. So today we are going to see about IO functions. So let me take a pen here and change that pen color to black. So here we are seeing about how to configure the pins. So we are having analog pins, 5 analog pins and 14 digital pins. So these pins should be configured as either input or output. So input means the user is going to provide some of the information. It can be in the form of buttons, that is push buttons, or it can be in the form of any sorts of analog sensors, analog or digital sensors. So output means it can be like in the form of providing an output from an microcontroller. So it can be an LED or it can be any sorts of output devices. It can be LCD one or it can be any sorts of other output pins. So it can be in motors. So it can be motors or any sorts of output pins. So let us dive in for the sessions. So pins to configure as an input. So by default, all the pins or input have been configured as an input in Arduino. So in many of our microcontrollers, the default pins will be configured to a input itself. It can be ARM or it can be other microcontrollers. So all pins will be defaulted to the input pin. So whenever the pins are going to be in an input, it will be in a high impedance state. So what is this high impedance state means? It is not going to give any amount of current to the respective pins, what the devices to the respective pins which have been connected. So if you are connecting any sorts of input devices, so what we have been just discussed here, like button or any sorts of sensors. So consider the third pin have been configured as an input. From this third pin to that sensor, we are not going to send any higher currents. So that is going to be called it as an high impedance state. So it is not going to provide any of a current to the respective devices which we are going to connect, and we are going to call it as an input for it. So input pins, so that is what it makes extremely smaller demands on the circuit, like connecting 100 mega ohm to that respective pin in series for that respective pin. So this is like 100 mega ohm means it is not going to allow the current. So this is what I was being just explaining. So that is called as a high impedance state. So in order to make any of the pins to work as an input, okay, Pinmode is a function name in an Arduino. You are going to use it. So you are going to decide what is a pin number? It can be 13, it can be 12 or anything. So that pin should work as an input. So this should be in caps. Input whatever mentioning, that should be in caps. So pin number, so pin mode, P is small here. So okay, then pin mode. Pin mode 13, and you need to say that it is an input, and input should be in capital letters. So this is all about how to configure the pins as an input state. So pull-up resistors. So pull-up resistor means it will be always pulling our voltages to the source level. So if the source is 5 volts, so instead of giving the current to the other supply, it will be pulling that resistors towards sources or towards a sink. So it is used to steer the input pin to known state if input is not present. If the input is not present, so that pin need to be steered to some sorts of a state. So that is can be like an impedance state, low or high. So that is going to be done by this pull-up resistors. So how to do this? To pull any of the input pin to the known state by adding pull up or pull down resistor to the input pin. So you consider this is a 13th pin. So you can just connect some kinds of a pull up or a pull down resistors to the input pin. So this is pull down. So if it is being connected to VCC, it will be working as a pull up. So 100k resistor value is a good value to work as pull up or pull down resistor. So pull up means voltage will be pulling to the VCC. So if you have been connecting to the sink, the voltage will be running to the 0 volts. So how to access a pull up resistors in Arduino? So inbuilt resistors, pull up resistor, we are having 20,000 pull up resistors. So, but what is the difference between a respective pull-up resistors and an input is, it is going to have an inverse operation of an input. If you are providing, if it is providing a high signal means the sensor is off. If it is providing a low means the sensor is on. Oh, 1 second. So we was been talking about this respective pull-up resistors. So it is exactly an inverse operation of an input. So if it is high means the sensor is off. It is if it is giving a low means the sensor is on. So it is exactly an inverse operation of a input. So now let me just give an example to how to configure the pins as an input or as an output. So the example here is like, so pin mode. So considering the third, it need to work as an input. So this is a syntax and it should be written inside the void setup. So inside the void setup, you need to write this. So if you are going to configure any of a pin to work as pull-up resistors, so the thing is you need to give an input thing, that is a number, which pin you need to just work as a pull-up. So input dot pull-up. So this is how to declare this in an Arduino. So next we are having another topic here. Audio is working fine. Okay, pull-up resistors. How to configure the pins to work as an output pin. Okay, So I was been talking about how to make the things to work as an input pin. So now we are going to just discuss about how to make a pin to work as an output. So we are going to just provide a pin, so that is going to work as an output. So the pin is going to be assigned as an output, means it will be in a low impedance state. Low impedance state actually means that, so this pin can provide some of a current to the externally connected devices. So consider you are connecting an LED. So positive side will be connected to some of a terminal and the negative side will be grounded. So if you are going to make this pin to work as an output, so it can provide some of a current. So there will be some of a scenarios, like if this LED is going to draw more number of current, this pin will be going to enter into a dead mode, that is going to be damaged. In order to avoid it, we are going to connect a resistor in between output terminals and a Arduino pins, or it can be any sorts of microcontroller pins. We are going to connect in between a resistor. So the resistor value will be ranging from 470 ohm to 1k. So this is a range of resistance what we are going to just connect with. So why we are going to choose it? Again, we are going to have some equation. V is equal to I. So that is what pin can give 40 milliamps of current. So directly here we will be sending 40 milliamps of current, a very small current. So this can run LED sensors, but it cannot run relays, motors cannot be run. And here we cannot continuously provide this 40 milliamps of current. So it will be just damaged. In order to avoid it, we are going to just connecting a resistor in series to it. So preferably this is a value. So that is what I have been just explaining here. So now how to make this to work as an output pin. So let me just go to this thing. So output means we are going to write inside the setup. So the default LED will be connected to the 13th pin. So I am just making a pin mode. So the pin, I am just taking it as a 13, and I am just going for just making to work as an output pin. Okay, semicolon. So if you are going to connect any of the buttons, so that button is going to act as an input. So you need to choose it, whether it is input pull up or pull down, or any sort of a normal one. So this is a button. So this is like initializing. So here you can write if digital read. So you are going to read from a 5th pin. If that pin is equal to low. So if you are going to press a button, it is going to provide you a low signal to the pin. So you are just reading that signal, and it is a digital one. So the command here you are using is digital read from which pin? 5th pin. So what you are doing, if this button is pressed, you are going to write a digital write. You are just providing a high voltage to the LED. LED has been connected to 13th pin, and you are just providing high signal. So after providing a high signal, as usual, you need to provide a delay. So this will be in microseconds. So that we are being just seen in a time function. So you can generate in milliseconds, microseconds, and also this. If you are giving 1000 value here, it is going to generate 1 second delay. So after having a high signal, you are going to pass the low signal. That's it. And again you are going to generate some delay. So this thing will happen whenever the switch is pressed. Else there is no need. Delay function. So this is like how to use the output pin and configure the input pin. So this is all about how to configure the pins to work as an input and output. So now I have been just used the digital write in your programming part. So what does this digital write actually means that? So digital write is a function to write a high or low to the pins. So high means providing a high voltage. So in an Arduino, the high voltage means 3.3 volts. So the digital write can provide 0 or 3.3 volts to the respective pins. So this is like digital write. So its syntax is, so just you are going to use digital write. So W should be caps here, digital write, and you need to specify for which pin you are interested with, and you need to just provide high or low. So this is a syntax you need to just follow with for having digital write. It can be high or it can be low. So W should be in caps, and which pin you are making high and low. So this is a function used in an Arduino to make any of the pins to provide a high voltage or low voltage. So the example for this digital write, we can just go here. So again we are going to have a word setup. So in a word setup, we are going to make the pin mode, and the LED pin, the default LED is 13, and I am just decided to work it as an output port. So next comes void loop. So in a void loop, we are going to have digital write. W should be caps, and I am making the 13th pin to work as high signal. So delay, I am just making some random delay. So again digital write 13th to make it as low. So again I need to give semicolons here. Semicolon should be given, and I am just making it as a delay for 500. So this is like a void loop. What you are going to make it as a for digital write. Let me just connect Arduino, and let me just show you this how to just have a working. Okay, this is a default LED which are being connected to the 13th pin, and this LED is going to give whether the Arduino is on or not. So this two LEDs which is going to tell you whenever the dumping is going to happen, transmission and receiving. And this is a connecting wire. You need to connect this wire to this point here. Let me open Arduino. Okay, you need to push into a USB cable version. So the other part will be an USB head. So that should be pushed. So one thing is one end will be connected to the Arduino and another end will be connected to the system. That is a USB head. Okay, it may take some time. So digital write means it is going to provide you a high or low signal to the pins. So okay, fine. Let me just take, so whenever the Arduino is on, the on symbol, the LED will be glowing and you are being connected to this point. So now I am taking int LED is equal to 13. So by default you are having a one LED on board, so that is being connected to the 13th pin. So pin is connected to a, so LED chosen is inbuilt one. Okay, here inside this I am just making a pin mode. So pin mode LED to work as output. So you can just make a, see the changes here. Whenever there is a pin mode, it is an inbuilt command. It is going to change the color. So output is also an keyword. So you can just observe here. So these are the things you can just observe. So void loop, inside a void loop I am going to use digital write, and I am, for a pin I am writing a high signal. So you can just observe 3.3 volts will be going for 13th pin. Okay, we are generating a delay of some 500. So you have been just seen in a time function what is this microseconds delay is going to be just generated. So once this is LED is on, we are going to make it off and we are going to see. Okay, this should be in caps or else it will not take. So 0 volts to the respective pin. Okay, before going to execution, you need to select the Arduino Uno. My board is Arduino Uno. Next, you need to verify first whether the program is fine or not. So compiling. So if you are having any syntax error, you can just have a things here. Okay, once the LED is off, again you need to generate some random delay. Okay, you can compile it again. Oh, it was not compiled. Okay, done compiling. Okay, I have been made change here with the delay. Okay, compiled has been done. So we are not having any of respective errors. I am just uploading it. Uploading means to the Arduino to upload serial port not selected. Let me open a new one. port is not visible. Okay, let me just restart this. Let me copy this somewhere else. Let me change port of this. Okay, now port is available. You can just make it as a COM4. If this problem occurs for you as well, you can just restart the systems. That is, restart the IDE. You can verify this, you can compile it. So after compiling, you can just have a upload. Okay, it is just compiling here. Okay, we are not having any errors. You can upload a thing. Okay, it is uploading. So whenever it uploads, the LED will be blinking, the transmission and reception. So this is a 13th pin LED. So for it will be on, that it will be continuously on for some delay, and it will be off, and it will be in the continuous state of off till that delay is elapsed. Okay, you can just see the delays. You can raise a delay here from 500 to 5000. So let me just show you how this while uploading, how this LED will be just blinking, transmission and reception. So it has been programmed now. So now you can just see the on period, the delay have been more, off period also the same delay. So this is like how to change the delay versions on and off. So this is a digital writes and digital read. So the next one is analog read. Let me take a pen. Digital write and analog read or write is like in digital reading or reading. So it will be just pushing 1 or 0. But whereas in analog, the continuous values will be pushing. The continuous voltage values will be pushing. So in order to get these kinds of values, we are going for a function called analog. So analog. So analog and R should be caps. So whenever the sensors, analog sensors is going to give a continuous values like this. For this continuous values, in order to fetch all the continuous values, we need another function called analog read. But digital read is going to observe only high or low. So there will be only two signals, but here we'll be having a continuous signal will be passing. So continuously it will be varying like this. In order to have these kinds of signals, we need to just go for having another option called analog read. So let me just show you the program. So now this is just a program using a analog read. So int analog pin is equal to 3. So this is analog pin. So what it is going to do is it is taking some variable and the value of that variable is 3. That's all. Int val is equal to 0 and taking another value and we are just assigning it to the 0. So we are just having an analog device, so that is called as an analog knob. The middle pin of that knob has been connected to the third one, or the third middle pin has been connected to the analog pin's third pin. So void setup. So in a void loop, we are taking a value by using a analog read option, and from which pin? Analog pin. So this one will be printed, serial dot print ln, and what you are printing? Value which are being just generated from the analog. So let me just tell you what are all the devices which are being just provided. So this is like let me take a pen. So this is analog read. So there is another version called analog reference. So configure the reference voltage, use it for analog input. So you are going to configure the reference voltage. Why we need a reference voltage is like, so in a DAC conversion, you have been just seen about a ladder DAC. So in that ladder DAC, some reference value will be there. With this reference value, the input value or the value which have been coming from a pins will be compared. If it is less, you will be having a one output. If it is more, you will be getting another output. So during that time, you need a reference value. So that for analog input. So the default values will be 3.3 volts. Preferably, all the Arduinos are coming with 3.3 volts. Internally, the segments components reference value is 1.1 volts. External pins can be varying from 0 to 5 volts. So the types are default internal 1 versus 1. So this 1 versus 1 is going to give you the respective voltages of 1.1 volts. So it is being used only in Arduino Mega. So it is another type of a Arduino device. So next type is internal 2V56. So it is going to provide you a 2.56 volts, and it is also be used in Arduino Mega. So the external voltage we are knowing that 0 to 5 volts. So here you are having a reference pin, a reference. So that is an external pin. So this pin has been used to provide, or while making some of our DAC calculations, if you need any of our external references or internal references, this pin is going to make it. So then reading an analog pin. So this is one of a case study here. So we are just making a reading of analog voltages. So making pin 0 to make as an analog read. So analog read. So here this pin have been made as analog read. So here you need a one breadboard, you need an Arduino Uno, one variable resistor. So this is a variable resistor we are going to just see with. It is having a 3 pins, first, second and third. So this is of having a analog reading option. So the procedure is like you are having a Arduino, you are having a 0th pin. So this one will be connected to the analog read. So this 0th pin will be connected to the mid of a knob. So if this is a knob, it will be having a 3 terminals, first, mid. So the 0th pin of Arduino will be connected to the mid of a knob. So then this ground will be connected to the ground, and this pin will be also be connected to the ground, and here we will be having a breadboard connection. And here you'll be having some power supply that will be connected to the respective boards. So this is a connection. So let me explain about this knobs. So this knob is a version. So this is a resistance strip. So this is a resistance strips. Inside this you'll be having a contact. So this is a sliding contact. And you are having three terminals here, 1, 2, and middle one is third. So whenever you are being just sliding it to the lower end, if it has been, so this is a resistance string and this terminal is important, the middle one. So if it has been set it to here, smaller resistance will be provided, only this much. So if you are varying it to this extent, this many resistance will be provided. So the middle pin is going to tell you the resistance value. So let me just give you work like what is a working. I am just naming it as an X, Y, Z. So X will be here, Z will be here, and the third terminal is varying resistance part. So this is a varying resistance where you are going to just by rotating the knob, this is going to slide. So if this is going to slide and make a contact here, the larger resistance will be there. So this is a final resistance part. So the contact maximum. So this is a varying resistance. So it will be having three terminals. We'll be knowing about a variable resistance, variable capacitors and all. Variable resistance is like the middle one is being connected into our program as 0th pin. So this is a main thing. This middle one is a contact pin, what we are going to see here. So you are going to vary the resistance. So you're having one of a program on this. So void setup serial dot begin 9600 void loop so int sensor value is equal to analog read, and that too you are reading from A0 analog 0 pin. So next we are having some float voltage, so it will be like sensor value what you have been just read from the respective analog pin, sensor value into 5.0 divided by 23. So it is just a conversion here to just displaying into the readable format. So you are going to make subdivisions here and you are going to just provide your print ln what you are printing voltage. So this is one of a thing where if you are having any of analog sensors, you can just connect the middle part to this A0 and the other ends should be connected to the another parts of a circuit. So that is like another thing is a ground pin that should be connected to here. So these are all the connections what you are going to just do with whenever the provided analog readings have been just done with. So the middle part should be connected to this A0 and the first pin of analog knob. So here we are having three terminals. So this middle one should be connected to the A0 and this one should be connected to the ground here, this ground, and you are having another common ground here. So the first one, A0, is here, and the first pin or a first knob should be connected to this ground, and you can use another ground here. So this is like how the connection is going to happen. I will be just sharing the picture of it, or what is the thing what we have been just seeing here. So this is the exact version. I will be just sharing a pic of it. So that's it for this video, guys. I guess the sessions are informative. Let me meet you in the next video. Thank you.